Mrs. Hauser here with Unit 1, Lesson 5, Circles, and I've split this one into two parts. This is the first part of two. We are going to talk about the parts of a circle, how the radius and the diameter are connected to each other, how to find the center of a circle, and how to find an endpoint of the diameter. We'll also talk about how to find the radius and the diameter. All right, so what are our parts of a circle? Before we can talk about anything else, we need to know the parts of the circle. So the first thing I'm going to talk about is a chord. And I'm going to call this piece right here a chord. I'll highlight it for a second. I'm going to call it a chord, but actually the diameter is also a chord, but the diameter is a special chord. So I'm only going to refer to that one piece as the chord. And a chord is a segment whose endpoints fall on a circle. We'll also talk about a diameter and a radius. A radius is not a chord because both endpoints are not on the circle. And I actually see 3 radii in this picture, but I have labeled 1 or 2 of them together as my diameter. So those are the important parts of a circle that we're going to talk about in this unit. There will be more coming up in future units, but for this unit, these are the important parts. And what we also want to note are what's important about a radius and a diameter. So what is important about radii? All radii are congruent. And I actually have an infinite number of radii. If I talk about a diameter, I can see that I have 2 radii. So a diameter is twice the length of the radius because I have 2 of them. I also have an infinite number of diameters. Okay. What else is important about the diameter? Well, if these 2 radii are in the same, then that makes this center of the circle the midpoint. It doesn't matter what diameter I draw in, this center of the circle will be the midpoint of that diameter. For instance, if I draw one here, this is also cut in half by that midpoint. If I draw one here, it's also cut in half by the center of that circle. So how can I find the center of the circle? I'm really just finding the midpoint. Okay, So I'm going to use that midpoint formula that I have, x1 plus x2 over 2, y1 plus y2 over 2. I also know that this is just going to average my x's and my y's. So now I'm going to substitute in, and every time I substitute in, I like to label my x coordinates and my y coordinates, 0.1 and 0.2. So x1 is 3, and x2 is 7 over 2. y1 is 0, and y2 is 6. I'll add those together, and I'll simplify it down. So now I know that the center of my circle is at the point 5, 3. Now they're asking me for the radius and the diameter of this circle. Well, I know that the radius is this measure here, but I need this point to be able to find out how long that is. So what I would do is actually find the center or the midpoint of this circle. So again, I'll use that midpoint formula. I'll label my points. And I'll substitute their values in. Those are my x's. And my y's. 3 plus 9 is 12. And 4 plus 6 is 10. I'll simplify that down and I'll get 6, 5. Okay. And now I want to look a little bit about how I could find that distance. I could use the distance formula, which is not a problem, or I could use the Pythagorean theorem. If I were to use the Pythagorean theorem, we need a right triangle. But how do I know how long each side is? Well, if I'm going from 6 to 9, it took me 3 spaces to get there, from 6 to 9. And if I'm going from 5 on my y to 6, it took me 1 space to get there. So even though I didn't graph this, I know that it should be to the right 3 and up 1. So I can substitute that into my Pythagorean theorem. If you're not comfortable counting like this, you can always graph these points. That's never a problem. So you get a piece of graph paper and graph the points. I know that I'm trying to find the radius, which would be our C. 3 squared is 9, 1 squared is 1, and I have C squared. I have 10 is equal to C squared, and I would take the square root of each side, which would give me C is equal to 10. It's going to be some number that's a little bit bigger than 3, but we'll leave it as radical 10 for right now. And so that's my radius. So if I wanted my diameter, the radius is equal to radical 10. My diameter would just be 2 times that value, 2 times radical 10. And I could just say 2 radical 10 if I wanted to. Okay. The last thing we're going to do in this lesson is find the other endpoint. So I know that this is my center and my midpoint. So again, I'm halfway there. So what I'll do is I'll count how much I have to move to get there. So we'll move to the right first. That means I'll be looking at my x's. And when I go to the right, I go up by 2. So I know I moved to the right 2. Now I'm going to look at my y's. And I see that I increased by 1. So I know I need to go to the right 2 and increase my y by 1. So if my x increases by 2, it's going to be 3 plus 2, which is 5. And if my y increases by 1, it's going to be 4 plus 1, which is 5. So I just found the other endpoint of my circle. So this is an application of something that we've done in the midpoint lesson. And in the midpoint lesson, we actually graphed these points and used a graph. And if you're having trouble doing it the way I just did, you might find it easier to take out a piece of graph paper, graph the point 1, 3, graph the point 3, 4, and count the boxes. And there's absolutely nothing wrong with that. It's a perfect approach to this problem. If you have any questions on any of these problems, come see me and I'd be more than happy to go over them with you.